Hello everyone. Today we will talk about sound waves 6.3. Example of sound wave, it's the speaker. When a loudspeaker cone vibrates, here it's a speaker. So as we know, the speaker, it has the cone here. So when this cone it vibrates, so what will happen? It moves forward and backward. Here, as you can see, this the cone will move forward and backward. So this movement backward and forward, it will what? It will affect on the air particles that are attached to it. So what will happen? It will push this air particles. So as this squash and stretch the air in front. So as a result, a series of compressions and refractions travel out through the air. So here, if we will draw it, it's the cone and the air particles are here. So what will happen when it will move forward? It will form the compressions. When it will move backward, it will make the refraction and so on. So compressions, refractions, compressions, refractions, and so on. Here we have some facts about sound waves. Firstly, in 6.1 and in 6.1 we talked about the two types of waves. We said we have two types of waves, transverse waves and longitudinal waves. Now, what do you think? Sound wave, it's which kind of the waves? Is it transverse or longitudinal wave? Depending on what we explained here, because we say the oscillator or oscillations, it will moves backward and forward. So the movement of backward, forward, it means what kind of waves? It's this one. It's the longitudinal waves. So sound waves are longitudinal waves. Then sound waves needs a material to travel through. What do you mean by this? If we will come back here, we will see. This is the speaker, and let's say you are here, okay? Okay, now there is a distance between the speaker and you. So the sound to travel from speaker to your ears, it needs what? It needs something to pass through it. It needs a medium. It needs a material to pass through it. What's this material here? It's the air. So sound waves needs a material to travel through. This material is called medium. Without it, there is nothing to pass on any oscillations. So sound always it travel through medium, through a material. It will never travel through a vacuum. What do you mean by vacuum? As you know, it's completely empty space. Then here sound waves can travel through solid, liquid, and gases. Okay, so because here we say in this point we say sound waves it needs medium. So this medium it could be solid, liquid, or gas. Okay, then sound waves can be reflected and refracted. In 6.2, when we talked about wave effects, we talked about some evidence about waves. We said waves, all waves it reflect and it refract. So same thing here, it's with sound waves. Sound waves, because they are waves, so it can reflect and also it can refract. Okay, again, to remind you what do you mean by reflect and refract. Here, reflect, it bounce off. Okay, when a wave, it hits a material, it hit a solid surface, so it will reflect. Refract, what do you mean by refract? When it will pass through two different mediums. For example, the sound will travel from air and then let's say solid and then liquid, or solid and then gas. So here we have two different mediums. So when we will have two different mediums, the sound waves here, it will refract. In another way for refract, it means it will bend. Number 3, sound waves can be diffracted. What do you mean by can be diffracted? It means the sound waves, it will bend when it pass through a gap. Another definition or another explanation for it, they spread through gaps or bend around obstacles. Here we have experiment that it shows sound waves to travel, it needs a medium. So here, if you look at this drawing or this tool, it's what? Here we have electric bell, we have source of energy, which is battery, and here we have vacuum pump. Firstly, here there is air, okay? Air particles. So if you will give energy for this electric bell, it will start ringing and it will make sound. Okay, for example, if you are standing here, okay, so you will hear the sound. Okay, but then if they will take all the air from this jar or from this tool, okay, what's that mean? Here it will be empty. There won't be any air particles, and they will give energy for the ring. The ring will start ringing, but you will not hear the sound. Why? What happened? Because there is no any air particles, there is no medium here, so the sound, it cannot move, it cannot be traveled from ring to you. Displaying sounds. How we can see or how we can display the sound waves? We can display the sound waves using a tool, we call it oscilloscope. Okay, this is oscilloscope. As you can see here, what do we have? We have microphone, okay, and we have this device which is the oscilloscope. The principle of this oscilloscope or how it works. Here we have microphone. So when you will talk, or if you will give any sort of sound, okay, or let's say when you will talk, this air particles, it travel until it goes to the microphone. It will affect on the microphone. Inside microphone, okay, here, when sound waves enter microphone, they make a crystal or a metal plate inside it vibrate. So inside the microphone, we have a plate. This plate, it will start vibrating. So these vibrations, okay, are changed into electrical oscillations. So here we have sound waves. It hit the microphone. It makes the plate inside it vibrate. Then this vibration will be converted into electrical oscillations, and these electrical oscillations will be showed in the oscilloscope, the screen of it. Okay, then this vibrations, the size of these vibrations, it will depend on the sound, okay, how strong it is, okay. It could be in this way, this much, it could be this much. It depends on the sound strength. Reducing sounds. Sometimes loud sounds, it's not something good, okay. For example, let's say when you will go to cinema, firstly you will look at the walls of the cinema, on the floor of the cinema, you will ground of cinema, you will see all of it, it's covered with carpet, okay. Why? What's the reason behind covering the walls and the ground and everything with carpet? The reason behind this, it's what? Hard surfaces reflect sound and can cause echoes. Okay, what do you mean by echoes? It's like sometimes when you will talk, after a while you will hear your sound again. Okay, it's something, it's like someone is repeating what you said. This is what do you mean by echo. So to prevent this problem, to prevent this issue, so what they do, they cover the surfaces with a material, a soft material that can absorb the sound. It will not reflect the sound. So it could be curtains, it could be carpets, okay. So here it's the like cinema, something like that. And one more thing, it's houses near to airport, okay. If you will focus on the walls, or the windows of it, if you live near an airport, double glazed window are essential in this situation, okay. Here what we will have the windows, it will be like this, it will be the glass of it, it will be double, okay. The benefit of double, it's what? Inside here we will have air, this air will be removed out, then at the end here it looks like it's a vacuum, okay, empty space. So here the sound that it comes from the plane, okay, it will not travel to the other side. Why? Because here it's vacuum, it's empty space, there is nothing to carry waves through it. Here are some questions about what we studied today. So this, it will be your homework for this lesson. Have a good day. I hope you got benefit from this video. And again, if you have any questions, please just text me. Thank you.